This is a quick description of queues, data structure. So what is a queue? A queue is first in, first out. So you think about it when you join a queue, you join at the front, you join at the back, and you leave at the front. So the first person to have joined the queue is the first person out, unless you jump the queue, which you shouldn't. There are a couple of things about queues. There is a head of a queue, there's a tail of a queue, the end and the beginning, right? And there's some functions, Enqueue, Dequeue, and peaking. Where can you use queues? Think of a printer queue. You send something to the printer, it joins the back of the queue. Where else can you use queues? You could use them such as they're used in processors when deciding which process to encode and execute next. So yeah, they're used in lots of different places. The example here I'm going to take you through is going to help you answer the 2018 past paper question, which is right at the end here. So after we've done the code, you should go and answer these questions, and then you should look at this past paper question. And because we've gone through it in a lot of detail, you should be able to answer it quite easily. But it's really important to get your head around the code, and I've tried to code it in a way that matches that. So let's get started. One possible implementation of a queue is using an array, right, as they've done in the past paper question. So let's jump to here, go and create a new replit, call it queue, and I'm going to call it queue for YouTube because I'm doing this for YouTube. You can go and grab this empty source code here. So the first question they actually ask you, or you can look at this, is to create the item queue class, which has an array of called the items of size 10, and it consists of items. Then it has a head, which is an integer, tail, an integer, number of items, which is an integer. Then it has a constructor. Then it has the functions enqueue, dequeue, and then to set and get function to set number of items. So if you think you know how to create item queue from that, then give it a go. Be good practice at OOP. If you're not sure, we can jump down here and we can copy all of this code and we'll paste it in after the program class in here. There is a second bit of the question which gets you to create a struct or a record struct called items. That's because or item. That is because if you look in item queue here, if I blow this up so it's really big and you can see it. If you look in item queue here at the items array here, it is an array of items. This is a class, so we're going to hold 10 of these inside of this array here, right? So the item queue is going to manage this array of items. It has a head and a tail and has a number of items which we're going to use to determine whether the queue is empty. I'm just going to move my stuff over here so I'm not blocking the code. And it's something called a struct. So I'm going to do another video on struct, but if you want to have a look at that, I've put a link here about the difference between a struct and a record. So we'll come back to that. But in essence, in summary, a struct is a value type, a class is a reference type. Basically, a struct is used to hold information that's very simple. A struct doesn't have any functions, doesn't really have any abilities, whereas a class does. Right, so we've got this code, let's talk through it. We've got those properties, then we've got something called max size. Max size is 10, that's just a helper variable. They don't actually have that in the exam paper question, but they should, because it means you don't have to write 10 around everywhere. Then we've got our constructor. This constructs the properties. So we've got an array of the items that's of size max size, so 10 items. Then the head and the tail are 0 because the queue is empty when we construct it. And then we've got number of items, which is 0 when we construct it. And then we've got the two functions enqueue and dequeue, which we're going to write. And then we've got get number of items and set number of items. So that will get and set the number of items in the queue. So that could perhaps that could change it. I'm just wondering why they actually have that in the question. They don't actually ask you about it necessarily. Anyway, so the next question is, can you write the code for Enqueue? So let's think about how a queue works. When we enqueue something, let's go to Paint for this. Let's get some shapes. So I'm going to get when I enqueue something, and get some text. So the tail equals 0, head equals 0, number of items equals 0. Say I'm going to enqueue something. Hopefully I'll be able to edit that later on. I'm not sure if we can. No. I need to get one of those drawing pads, I think. That would be really helpful. Like and subscribe, and maybe I'll be able to afford one day. So say like we're going to enqueue this thing into the queue. Let's put some more shapes. So this is the queue. It's just going to have like 10 items. Like this. 5 items. Yeah. So too many. The head and the tail is 0. I enqueue this thing to the queue. It's an item. Oh, well, it's just a number here. But what do we need to do? Well, we need to the head is still 0, the index 0 of the array, but the tail is going to be, see if I can erase this. The tail is now, instead of 0, it's 1. And the number of items is going to be 1 as well. So when we're enqueuing, we need to update the tail and we need to update the number of items. But we don't need to change the head. So that's exactly what we're going to do right here. So let's go to Enqueue. There's an error in Enqueue. Why? Because Enqueue, as it says in the question, Enqueue takes as a parameter the item to insert in the queue. So we're going to take item as a parameter. Then we're going to check if the queue's full, right? Report an error and return false. It is full. If it isn't, we need to add the thing to the queue, add the item to the array at the tail position and adjust the pointers and then return true. Also, we need to update number of items because it currently stores the number of items currently in the queue. So we need to write that algorithm. So we're going to do this right now. So firstly, we need to check if number of items equals max size. So if it's full, then we're going to return false. However, if that is not true, so let's make a note here, queue full, return false. However, if that is not true, we're going to take the items and then at the tail position, which is currently 0, we're going to insert this item here. And then we're going to increase the tail by 1 because the tail pointer is now going to point forward. And then we've got a number of items, and we're going to also increase that by 1, and then we're going to return true. Now, you might not have thought this, but you might have thought, like, say we fill these up and then we start dequeuing, so we have an empty space at the beginning. Can we go back to the beginning? That would be called a circular queue, but I don't think their example requires you to think about that. But an extra piece of code you could put is, when you're enqueuing, if the tail equals the maximum size, then loop round to the beginning, so if that space is free. But we don't need to do that. We just need to remember this simple bit of code. Check if the queue's full. If it's not, insert the item at tail, increase tail pointer, increase number of items. So that is Enqueue. Right, so now can you pause the video and see if you can program Dequeue? So let's think about that, and I will show you the answer as well. So say we've got a few things here, like 3, and then we've got 5, right? So the tail is now 0, 1, 2, 3, right? So we're just going to erase that. This is not a great tool, is it? Tail is 3, 0 in terms of the index, 0 index, 2 is at 0, 3 is at 1, 5 is at 2, so the tail is here. If we're going to dequeue, what do we need to do? Think about the algorithm. Well, we're going to need to check if the queue is empty. How can we check if the queue is empty? Well, if number of items is 0, then we can't dequeue anything. So we should, I think when we're dequeuing, you need to return the item that you're dequeuing from the queue. So first we need to check if the queue is empty. If it's not, if it is not empty, then we need to dequeue from the front of the queue. You always leave from the front. The first in is the first out. So we dequeue at the thing at the head. Then we'd increase the head by 1 so that 3 would become the new head. And then we'd reduce the number of items by 1. So let's just write those as comments. See if you can write the code for this before I give you the answer or you look it up. And if you are doing this on Replit, by the way, the AI is really helpful, but like when you're learning, I really think just trying to think through problems is better. Turn it off because it will write Dequeue for you. So what do we want to do here? Check if the queue is empty. Is number of items equal to 0, right? If it is not, get the item at the head of the queue. Increase the head by 1. Decrease number of items by 1. And then finally return the item we are dequeuing. Why do we return it? Because that's what we're saying here. We're saying that, so normally you would. So pause that, have a go at that if you like, and then I'll show you the solution straight away. So I'll show you the solution now. If you did this, well done. If you said number of items equals 0, return null. So return null because item, like we need to return an item. If we can't return an item, then we're going to return nothing. There's going to be an error here, so I have to put an exclamation mark here. Why? This is a complicated thing in programming called optional. It means that I'm allowed to either return an object or nothing, right? So that's all you need to remember about that. Don't worry about it too much. It's a C# thing. If you're doing this in pseudocode, you wouldn't need to do that. Right, so if the queue is not empty, then get the item to return, get that item from the items at the head, right? So that's the thing that we're going to return at the end. Then we're going to increase the head by 1. Then we're going to, number of items, we're going to decrease it by 1. And then what we're going to do is, light's going to turn off. Then what we're going to do is we're going to return this thing that we just dequeued, right? So that is how you dequeue from a queue. And this is how you enqueue. And then in the queue, these are the items. It's a struct. Go into a more detailed explanation on what that is in another video. Yeah, so I was saying, can you do this? Here's the outline of the code here. Answer these questions on the code, and then have a go at answering this past paper question here. It's quite a long one, and I think they ask you to do a few other things. such as to test out this queue works, we're going to need to create an instance of item queue. Let's call it the queue, and then we say new item queue, right? And then we're gonna enqueue some things. What can we enqueue? Well, we've got to create an item first. We've got to create a struct item. So we're going to have to create an object item. Let's call it shoes, because it's going to be, it looks like an item for a shopping website or something. And you say new item, and then we pass in shoes, price is $23.99 or something. The date is a string. I just said so. Let's say it's today, 15/01/2024. That's the date today. What year are you watching this in? Maybe you're watching this in the far distant future. Who knows? And has it been transferred? I'm not sure what that means is, but that's just what they had in the example. So now we can enqueue this item. See if you could enqueue a few more things, and then see if we can then dequeue something. So we don't need to pass anything into dequeue. We just call it, and it will dequeue the thing at the front. And what will it return? It will return an object of type item. We can check. Oh yeah, it's because it's this optional thing. I think that's got to be optional. And then we can do a console dot write line, and we're going to dequeued, and we're going to print out the what things can we get from items that are not they're all private, so you'd have to create getters and setters. So let's just make them all public, so cheat a bit. Item name, I'm just gonna thing that gets dequeued, because it's optional. You've got to use this question mark. It's going to get a bit confusing for people who don't understand this, but basically that means we're checking if that just happens to be null, because it could be null. The queue could already be empty, and we can't get the item name from an empty null item, and it will crash. So we have to use this question mark so the computer won't crash. So it will test it first before it tries to go and get it. So then we can get the thing that we've dequeued. So if I run this now, what should get printed to the console is shoes, because it will print out the item name. So if I run that, and that's basically what they're asking you in the rest of the question. How do you create an instance of the item object? How do you enqueue and dequeue things? There was a slightly different question on, and there's one on caching and concurrent processing, which is actually nothing to do with this topic. Well worth looking up. So look, it prints hello world, which we can get rid of, but then it prints the thing that is dequeued, so we know that it's enqueuing and dequeuing correctly. I'll obviously put a link to this code in the article, but that's all I really wanted to do, and that is the concept of queues, the data structure.